In the beginning, the solar system is a swirl of gas and dust. Little by little, it clumps together, smaller chunks of material plunging into larger aggregations. They form the planets. A giant star is dying. It explodes as a supernova, the shockwave blasting through space toward a cloud of hydrogen. The cloud collapses, forming rings of gas and dust. At the core, a nuclear furnace fires up. Our sun is born. So too, the 9 planets of the solar system. This empire of the sun is like a bubble. It's called the heliosphere. Within, the sun reigns supreme. So what is the sun, this local star of ours? Deep inside, at 27 million degrees Fahrenheit, it's a nuclear reactor turning hydrogen into helium. Each second, the sun loses 4 million tons of mass, matter that's unleashed as energy. Slice open the sun, and we see the path of that energy. From the white-hot core, it takes 1 million years to reach the surface. It takes just 8.5 minutes for that same energy to speed the 93 million miles to planet Earth, energy we call sunlight. By analyzing its spectrum, especially the pattern of dark bands, astronomers discover the composition of the sun. It's 73% hydrogen, 24% helium, plus a sprinkling of heavier elements. This is the solar surface, the yellow photosphere, temperature about 10,000 degrees, and above it, the fireworks of the red chromosphere. We look down on the photosphere, gas boiling up to the surface, cooler gas descending, each bubble the size of Texas. Not a sunflower, but a sunspot. Such blemishes periodically pock the sun. They're cooler than the surrounding photosphere. This one could swallow Earth. A group of sunspots. They can grow in 10 days, fade in 2 weeks. Here, the rotating sun has a spotty face. At other times, it's spotless. Sunspots indicate magnetic activity. They show where force lines burst from the sun and where they re-enter. The sun is like a garden sprinkler, swirling vast magnetic loops. Every 11 years, the magnetic poles flip. Midway between flips, the sun is at magnetic maximum. Its force lines generated by gases just beneath the surface. The surface spins at different speeds. At the equator, it rotates once in 26 days. At the poles, it takes 37. This tangles and distorts the magnetic field. The result is a seething ocean of energy, our star unmasked. Within the chromosphere, the inner atmosphere of the sun, arcs of gas sweep around magnetic force lines. Prominences leap into space, forming arches 30,000 miles high. Eruptions spew from the granulated surface. Prominences are surges of flaming gas triggered by magnetic releases deep below. These are major prominences, jets licking up to 60,000 miles. Tiny Earth is set in to scale. But flares are more violent. They eject with the energy of 10 million hydrogen bombs. A flare blasts ripples across the solar face. The outer atmosphere of the sun, the corona, is visible at a total eclipse when the moon obscures the solar disk. The corona is hot, nearly 4 million degrees, and it dances a magnetic jig. Convulsions on the solar surface shape the activity above. From the sun, that searing pivot of the solar system, it's an average 36 million miles to Mercury. Outwardly, Mercury is like our moon, rocky, cratered, barren. But inside, like Earth, is an iron-rich core. That core is as big as the moon, and at 70% iron, Mercury is the densest planet of all. Mercury is battle-scarred, scorched and irradiated by the nearby sun, an ancient landscape of craters, cracks, and basins. This is one side of Caloris, the site of an impact that gouged a multi-ringed basin 800 miles wide. The culprit is a planetesimal, a lump of primordial matter. Such missiles rained in torrents upon the early planets. Mercury is riven with cracks, many of them the result of the Caloris impact. It may also have caused this lava plain, molten rock surging from beneath. But most plains post-date Caloris. They formed as crack-spewed great seas of lava. In contrast, Mercury's highlands have much sharper features. The epoch that created these plains runs for 1 billion years, but for the last 3 billion, there's been no volcanic activity. Mercury is inert, the interior solid. All that disrupts the surface are random whacks from space, calling cards like these. The arrow shows how slowly Mercury spins on its axis. It turns only 1.5 times in a single orbit of the sun. The result is a crazy calendar. It means Mercury's day is twice as long as its year. The day lasts 176 Earth days, the year just 88. It gets stranger. If you stood on Mercury, you'd see the sun apparently shrinking in the sky. It's to do with the variable distance of the sun. For the planet has an elliptical orbit. The sun appears larger when Mercury swings close, far away, and it's half the size. The result, on the planet, is a double sunrise. The proximity of the sun means Mercury is hot. At midday on the equator, it can hit 810 degrees Fahrenheit. The planet has a temperature range of nearly 1100 degrees, the greatest in the solar system. At midnight, on the dark side, it can be as cold as -270. With a diameter of just under 3,000 miles, Mercury is the smallest of the inner planets. It has an atmosphere so rarefied as to barely exist, a magnetic field just 1% of Earth's. Venus, the veiled planet. Venus, choked in smog, a crushing atmosphere of carbon dioxide. Venus, shaped by volcanoes. Venus, where day and night it's always 900 degrees Fahrenheit. Yet no sun ever penetrates these poisonous skies. Venus is a puzzle. It rotates just once in 243 days, yet clouds race around the planet in 4. And with a diameter of more than 7,500 miles, Venus is almost the size of Earth, but few twins are so different. Once, Venus may have been like Earth, with oceans, continents, and clear blue skies. So what befell this unhappy world? What clouded its face? The unveiling of Venus begins with radar. Astronomers have their first image of the surface, and with it, the discovery that Venus rotates backwards. (1966), and the Soviet Union starts sending landers through the clouds, the Venera missions. They detect an atmosphere 90 times denser than Earth's. Several craft are crushed. But a soft lander grabs these pictures. These are fractured slabs of lava. It seems Venus is massively volcanic. The images are beamed to Earth moments before the cameras frazzle, for machines don't survive here, much less human beings. If we ever reached the surface, we'd be instantly crushed. And to add to the horror, the upper clouds are bathed in sulfuric acid. Venus, rendered on computer. Heights are exaggerated and color guessed at, but otherwise the features are accurate. Three impact craters, rare on Venus because only the biggest space rocks make it to the surface. The rest vaporize in the super-dense atmosphere. Volcanoes with radiating lava flows. The Cleopatra crater, its rim breached by lava. Everywhere evidence of volcanic activity. Volcanoes have belched here for possibly billions of years. No one knows why. And eruptions may still occur, their sulfur adding to the toxic atmosphere. Lava relays the surface time and time again. Many parts only solidify within the past 500 million years. And despite the volcanoes, Venus is remarkably flat, like an ocean bed smoothed by the motion of currents. Here, the Venusian winds have carried ash from a volcanic dome. These upwellings of lava seem squashed by the sheer weight of the atmosphere. Pancakes in a barrel of syrup. Deeper inside, Venus is rather like Earth. Same density, same crust, same mantle, same core. The core is solid, probably a mix of nickel and iron. But unlike Earth, there's no molten outer core. As a result, the Venus of today has little or no magnetic field. Mars, Earth, and Venus mark out the habitable zone of the solar system. Venus, closer to the Sun, is at the zone's inner edge. But did it once have water, oceans, and continents? Billions of years ago, it may have been this way. One theory is that the Sun, much closer and hotter than on Earth, slowly evaporates the seas. Water vapor fills the upper atmosphere. There, it's split by the heat of the Sun. Hydrogen leaks into space. With carbon dioxide released from the oceans, the atmosphere thickens. Heat can't escape. There's a runaway greenhouse effect. Venus is trapped in a giant pressure cooker. In the ferment of the early solar system, Earth has neither life nor water. It's a molten rock. 4.5 billion years later, and the heaviest elements have sunk to the center. The inner core is solid iron and nickel. Around it is the molten outer core. Around that, the mantle. Earth's magnetic field and its wandering North Pole are caused by the solid inner core sloshing about in the molten outer core. As the toxic gases of our early atmosphere condense, rain starts to fall. Pools become lakes, lakes become oceans. Today, they cover 70% of the planet. They lock up carbon dioxide, bequeathing us an atmosphere 1/5 oxygen, 4/5 nitrogen. And other forces are at work. By night, the stars seem to travel across the heavens, but it's an illusion. It's the effect of Earth spinning on its axis, a 24-hour rotation that gives us day and night. It's the same with the Sun. As its shadow creeps across a dial, the Sun isn't moving, it's the Earth. Day and night would always be the same length if the axis of our planet weren't tilted 23 degrees from the vertical. Add the complication of Earth's orbit around the Sun, and the seasons are explained. An orbit takes a year. Each day, the angle at which sunlight falls on Earth changes slightly. Over a season, it's a lot. Over 6 months, the change is greatest of all. From this position, it's winter in the northern hemisphere, summer in the south. Short, cool days in the north, long, hot days in the south. 6 months later, when Earth is at the other side of the Sun, it's summer in the northern hemisphere, winter in the south. But fundamental to climate is the Sun. At the equator, where it shines most directly, it causes hot, moist air to rise. This drives 3 great engines of air that circulate between the equator and the poles, air that rises and falls. It's the reason for our winds. If Earth didn't spin, they'd blow north and south. Since it does, they're slewed to the east or to the west. A ring of debris orbits our red-hot proto-Earth after the impact of a planetesimal nearly half our size. This collision is thought to have formed the Moon. It solidifies into a mare, a sea of dark rock. Such upwelling ceased just over 3 billion years ago as the interior hardened. This is the surface of today. Uneroded by wind, water, and bare of vegetation, it is a stark record of impact after impact after impact. At more than 7,900 miles, Earth is nearly 4 times as wide as the Moon and 80 times as massive. Fly to the Earth. But tidal drag is slowing that spin. Simultaneously, Moon and Earth are pulling apart. Ultimately, our planet will spin only once every 47 days. And Mother Earth is subject to another tug of her satellite. It makes her axis wobble. The cycle lasts nearly 26,000 years. Sunup on Mars, the dusty red planet. Mars is fascinating, for it's the world where we will walk next. It's a little over half the size of Earth, but there's much in common. Mars has an atmosphere, seasons, and a day of 24.5 hours. But the red planet is bitterly cold, at best just above freezing. The Sun is at an average distance of 142 million miles. One solar orbit takes 687 days. Mars, setting behind one of its 2 tiny moons. They're probably ancient asteroids, petrified rocks captured by an ice-cool planet. Geologically, Mars has a divide. To the south, older cratered terrain. To the north, younger lava plains. For when dust storms kick up on Mars, they can last for weeks and envelop the planet. For an idea of scale, superimpose North America on Mars. The distance from coast to coast is some 2,500 miles. That's the length of the red planet's greatest rift, Mariner Valley. We take a second look, but from closer to the surface. Skimming the craters of the southern hemisphere, we turn west to fly the largest geological fault in the solar system, Mariner Valley. To the highlands west of Mariner and the volcanic dome of Arsia. Another called Havonis. A third named Ascraeus. But this is the volcanic peak that tops them all, Olympus Mons. Rising over 16 miles, Olympus Mons is 3 times the height of Mount Everest. These cliffs alone are nearly 4 miles high. Olympus Mons is the biggest volcanic peak in the solar system. There's a theory of oceans forming on early Mars because of immense volcanic upheaval. Eruptions melt subsurface ice, quickly flooding the planet. A respectable atmosphere develops of carbon dioxide. Temperatures soar. So why doesn't Mars go green and spark life? One factor could be climatic instability caused by huge variations in the tilt of the planet. But the main reason is volcanic shutdown. No major eruptions to replenish the atmosphere. An atmosphere slowly leaking into space because of weak Martian gravity. Could microbes survive here, bereft of warmth and water? And could we? Is this dusty world a place for human beings? Only time will tell. Jupiter is a giant ball of gas, bigger than all the other planets put together. Jupiter spins like a top. It has the shortest day of any planet, turning once on its axis in less than 10 hours. Glimmering through Jupiter's ring of dust, the Sun is but a beacon 485 million miles distant. So remote that it takes Jupiter nearly 12 years to orbit the Sun. Jupiter dwarfs our planet. It needs 11 Earths to span Jupiter's diameter, and over 1,300 to fill its volume. Where comets are concerned, Jupiter is like a vacuum cleaner. This comet, on a journey from the fringes of the solar system, swings a little too close. It's captured by Jupiter's gravity. Subject to forces hundreds of times greater than the pull of the Moon on the ocean tides of Earth, the comet fragments. It's July 1994, and more than 20 pieces of comet Shoemaker-Levy 9 plunge towards Jupiter. Jupiter is 90% hydrogen, the rest mainly helium. Haze tops the atmosphere. Then crystals of ammonia, ammonium hydrosulfide, water ice, and droplets of water and ammonia. Deeper, hydrogen and helium, liquid hydrogen, metallic hydrogen, and a rocky core. It's that liquid metallic hydrogen that generates Jupiter's magnetic field. This donut-shaped zone buzzes with electrified particles. But Jupiter's magnetosphere stretches much farther. After the Sun, it's the biggest entity in the solar system. And where the solar wind funnels toward the planet, auroral halos display around the poles as charged particles interact with the upper atmosphere. The 16 moons of Jupiter. Io is the most volcanically active body in the solar system. It heaves with eruptions. Lava relays the surface over and over again. Plumes feed the sulfurous atmosphere. Ganymede. At minus 240 degrees, the icy crust is more than 50 miles thick. Ganymede is the largest moon in the solar system, bigger even than the planet Mercury. Beneath the crust, a mantle of slush, then a layer of rock and ice surrounding a silicate core. Almost Ganymede's double is this moon, Callisto, except for the craters. They record eons of bombardment, the greatest impact site, a vast ringed basin. If there's extraterrestrial life in the solar system, it could be here, on Europa. Smooth and cracked like an eggshell, there's a theory that the whole moon is an ice-covered ocean, a possible medium for life. For the waters may be warm, heated by gravitational flexing caused by Ganymede and Io. But this ice may be many miles thick. To penetrate the ocean and search for organisms must await a landing. Nevertheless, the grooves and fissures that network the surface are cause for hope. They're reminiscent of frozen oceans on Earth and what life teems beneath their ice. The Big Four of Jupiter's 16 moons, a mini solar system. Our world is just 93 million miles from the Sun. Sweep out past Mars, last of the terrestrial planets, and cross the Great Divide to Jupiter. Saturn is beyond. This beautiful planet is nearly 10 times farther from the Sun than is Earth. Its solar orbit takes almost 30 years, its daily rotation 10¼ hours. After Jupiter, Saturn is the largest planet, so buoyant that in an ocean big enough, Saturn would float. Yet it could swallow Earth nearly 750 times. Like Jupiter, Saturn is gas, 94% hydrogen, the rest mainly helium, and it has similar weather bands, but haze makes them hard to see. Saturn's atmosphere has 5 layers, with haze at the top. Then crystals of ammonia ice, ammonium hydrosulfide, water ice, and water droplets. Deeper to hydrogen and helium, then liquid hydrogen, metallic hydrogen, and a rocky core. From afar, the rings of Saturn are like gossamer. Close up, there are billions of moonlets, from specks of dust to icy rocks the size of trucks. Some of the rings are kept neatly in orbit by little shepherd moons. Here's a pair marshalling the outermost ring. This moon, called Pan, orbits within the Encke division. But the rings are a puzzle. They may be the debris of pulverized space rocks, too close to the planet to clump together as moons. Within a few million years, the rings of Saturn may well disperse. Saturn's biggest moon, larger than the planet Mercury, is discovered by telescope in 1655 by the Dutch astronomer Huygens. The moon is Titan. And it's a little like early Earth in deep freeze. The atmosphere is rich in nitrogen, just like Earth. Temperature is minus 310 degrees Fahrenheit. Is Titan a laboratory for life? Seventh planet from the Sun, and orbiting on a strangely tilted axis, Uranus inhabits the twilight zone. Uranus is a gas giant with rings and moons. This one, Miranda, is the rough diamond of the solar system, a rocky little ice chip with cliffs taller than Mount Everest. It's cold out here. Uranus is 19 times farther from the Sun than is planet Earth. (1977). A star winks as it passes behind the planet. The winks reveal the rings of Uranus. Astronomers count 9. Subsequently, 11 are confirmed. They emphasize the severe tilt of the planet, all of 98 degrees. Uranus orbits on its side. With a diameter of over 31,700 miles, it's far larger than Earth. But compared to Jupiter, that's modest. The moving arrow shows the odd angle of the magnetic field through Uranus. Compared to the rotational axis, the magnetic axis is offset by 60 degrees. On Earth, it's only 11. The atmosphere is mainly hydrogen, with helium and a touch of methane. The upper band is a narrow layer of haze rich in hydrocarbons. Below, hydrogen and methane, ammonia and hydrogen sulfide, and a transition zone of gas and liquid. Deeper still, liquid hydrogen, a mantle of ices, and a rocky core. Uranus has 17 known moons. One of them, Miranda, is shattered early in its life. Some of the debris forms the rings of Uranus. The rest reassembles into Miranda Mark II. That's the theory. It's unproven, but it does explain the rings. Or perhaps Uranus is struck by a body the size of Earth. That could account for both the icy rings and the tilted axis. Either way, the chaotic contours of Miranda are like a moon reconstructed. Miranda, less than 300 miles across, is a riot of geological form. The most spectacular, these ice cliffs, up to 10 miles high. Fall from the top in this puny gravity, it would be 14.5 minutes before you hit the ground. Uranus, where a day is 17.25 hours and an orbit of the Sun takes 84 years. We've reached Neptune, last of the gas giants, last major planet. Neptune's solar orbit takes 165 years. This planet is 2,800 million miles from the Sun. Neptune, on the left, is denser but slightly smaller than Uranus. Our planet would stretch across Neptune more than 4 times, a width of just under 31,000 miles. To span Jupiter, 12 Earths or 3 Neptunes more than do the job. Neptune is the windiest place. At the equator, gales roar at 1,250 miles an hour. These cloud tops are cold, minus 330 degrees Fahrenheit. But the weather is driven by internal heat, something missing on Uranus. The Great Dark Spot. Over a number of days, it changes shape. To the southeast, another storm, the Wizard's Eye, bigger than any typhoon on Earth. Neptune spins once in 16 hours. The atmosphere is 85% hydrogen, 12% helium, the rest mainly methane. There are 4 distinct layers. The outermost is stratospheric haze with lots of hydrocarbons. Lower down, hydrogen and methane. Then ammonia and hydrogen sulfide, and a transition zone of gas and liquid. Toward the center, liquid hydrogen. a mantle of ices, and a rocky core. Neptune has two main rings. Parts of the outer ring thickened where material has clumped. In imaginary close-up, particles of icy dust. There are 8 confirmed moons. Triton, 1,680 miles across, Triton has the coldest known surface, minus 396 degrees, yet it spurts blackened nitrogen. These geysers shoot 5 miles high, their plumes carried downwind in the wispy atmosphere. Triton may be a captured planetesimal, like Pluto, the planet beyond, a world at the very edge. Far beyond is the Oort cloud, a swarm of freezing debris that shrouds the solar system like a sphere. Closer in is more icy trash, the Kuiper belt. Pluto, with its wide eccentric orbit, may well be a member of this belt and not a true planet. Pluto and its moon Charon have a combined mass of less than 1/5 of our moon, little frontier worlds of methane and water, frozen in the outer gloom. On average, compared to Earth, they're 40 times farther from the sun. 5 billion years from now, the sun runs short of hydrogen. It starts to expand. From a diameter of 870,000 miles, it floats to 200 times that size, a red giant. The nearest planets vaporize. Mercury, Venus, Earth. Then begin the convulsions. Like cosmic smoke rings, the sun puffs off a series of nebulae. The white-hot core is exposed. It collapses to the size of Earth, a white dwarf. Of the inner planets, only Mars survives in lonely orbit. Our sun expires as a dead black dwarf.